Welcome everyone to ESG 162L. So this is the engineering math lab. If this is something you've never heard of before, what you actually do in a math lab, don't be super concerned about that. What we're trying to do is we're trying to give you guys a way to actually grasp, sort of hold in your hands, as it were, the higher order math tools that we use and teach you how to use them like tools in the same way that you might be using something like a set of pliers, a screwdriver, a hammer, a series of sockets. Hopefully you didn't buy the cheap Chinese ones because they'll only last for a handful of jobs. You really want to buy the impact versions when possible. But I digress. We're going to cover a lot of things this semester. And what we're trying to do with this video series is try and get some of you guys caught up. So I don't know exactly what circumstances you guys are coming into these videos from. If you're just going through them to review, great, good on you. That's going to be better for you in the end than some of the other options. Now, there's some other things that we've got to cover. I'm going to go through some of the basic slides, and I'll try and make transitions and things as simple and straightforward as possible for you guys. Hopefully the audio should be okay. It looks like we're going all right so far. So we're going to press forward and record as many of these as we can and then get things set up so that you guys can actually see what the labs look like and how all this stuff comes together and then what exactly is a math lab. So what we're going to do is we'll set this up. I'm going to switch and see if I can get a clean presentation of the first kind of week of materials, and then you'll see kind of generally what happens. We won't be able to do some of the live feedback things, but you guys will get the general sense of what our topic looks like. So this is the way that I run my class. Some of the other instructors might be a little bit different, but this will still give you some kind of a flavor for what's happening. So let's take a closer look. All right. So I'm going to go ahead and run this and hopefully get a clean set of slides here. All right, so what we have, and this is what you guys would be watching on the screen normally. I'm Dr. Staggs. Welcome to class. This is a very interesting kind of class, one very much unlike anything you've ever done previously. And in a fantastic jump cut, we cut back here. I'm not sure exactly when this stops recording. Having some technical difficulties today on top of everything else. So I'm just going to leave it here until we stop recording and then piece together segments and do what we can here. So better is the end of a thing than its beginning, and the patient in spirit rather than the proud of spirit, because the anger is something that lodges in the heart of fools. You don't want to be in that camp. You're going to find in engineering a whole bunch of things that are going to frustrate you, but here's the downside is a lot of other things in other fields are going to frustrate you also. So spending a lot of time reacting to things like technical difficulties and less than ideal cameras shutting off all the time is not going to get you very far along. What you need to learn how to do instead is troubleshoot and problem solve and come up with creative ways to be able to do some of these things. So I won't stay in full presentation mode because that'll be too distracting. I describe a little bit in class about who I am. I've had the opportunity to work in a lot of different areas, especially in basic and applied research. Working with anything from biofuels and specialty chemical separations methods for the genetically modified organisms that develop biofuels, a bunch of things in and around that area, some really cool mad science projects that I was told to stop working on because they didn't understand them. It's usually how mad science works. And when I was at the National Laboratory, I got to work with a bunch of really, really interesting high-powered laser projects. And so this femtosecond pulse width laser that was an ultra-fast machining system we used allowed us to do all kinds of cool and interesting things. So to get through this material quickly and kind of get to the meat of things that we need, I typically do some kind of a quick icebreaker, get a sense of what people's cars are that they ought to be driving according to the internet, which is always accurate, as we know. So I haven't had time to do a tiny URL because I'm doing video recordings and all these other things in order to make some of this stuff work. So really super exciting and really works great. But this often will give results ranging from sports car to SUV to hybrid, and a bunch of people get offended if they get the hybrid, and then sports car or coupe are very common results, depending on whether you like to work on stuff yourself, whether you like somebody else to work on it for you, some of those differentiations. So this gives us some sort of a sense of where everybody stands, and it's kind of an entertaining way to do things. So then we ask what major everyone's in, and then what engineers do, and it shows up with some kind of series of results like this. They have to innovate, they have to design, they have to go through problem solve, they have to think, improve things, solve problems, fix things, repair stuff. There's a whole bunch that goes into this. So the overall structure of the class is going to look something like this, where you have a quick intro, you have some sense of what you're going to look at and work on that day. Then we have some kind of item like a spy photo of a competitor's product that we're going to shamelessly reverse engineer in this whole process. So there are a bunch of things that we're going to go through this particular semester. One of the other things that you really have to pay attention to in Halo is when you're looking through things, there's all of this stuff with the black and white. Those are called words, and we have to read them a lot of times in order to understand what it is exactly that we're supposed to be doing that day. Now, these are supposed to have been uploaded in a different format than they are, and there are some other issues specifically regarding the rubrics we're going to talk about later in the semester. A lot of the rubrics were put in incorrectly for this first run, so we'll talk about what's supposed to happen with those and what that's supposed to look like here shortly. But what you don't want to do is load up the topic and look at the prompt and then just download the file and assume you know what you're doing. A lot of times the file, at least in the case of this very first one, is going to be just an incomplete code file with no instructions. You're going to open it and be very confused. It's because you need to go back and read these word-looking things and understand what it is that they're trying to tell you. They were actually put there for a purpose, and we need to know what's on them. So what we're going to do is jump into this first assignment, and we'll see how well this setup will continue to cooperate. Hopefully it'll continue to record. So in Tinkercad, here's what we're going to be working with a lot for the semester. I have not set up individual classes for each and every one of you. Your instructor might, so they may have posted instructions in Halo. We're not going to spend a lot of time going through Halo, but we are going to go through a little bit of fundamentals in Tinkercad and circuit basics so that you can see how some of these things operate and function. So what you guys are going to do is, especially if you're following up and trying to catch up from at whatever point in the semester, what you want to start with is kind of walking through their tutorials that'll give you some sense of how the interface works and all these other things. So I'm going to create a new circuit. In this case, I've already got one open, so I'm going to hit Tinker this and jump down into this one and walk through some of the fundamentals and basics here. Each of you are supposed to be receiving a kit this semester where you have the Arduino Unos, and you have some breadboards, you have a bunch of other electronic components. So these are things that are going to be really, really helpful for you to be able to do a lot of the things that you're developing this semester. Not every single lab is going to be using these, but a bunch of them are. So I'm going to leave these components up for the moment. We're just going to look at a couple key features of the interface. So what we want to learn is how we can do things like select a component. We can change features about it, so we can change some of the colorations and other things. We can change some of how these operate. We can change the values for resistors by clicking them. By clicking a component and holding it, you can drag it around. By clicking, this is where you're really going to want a mouse for most of the things that you're going to do in engineering, especially as you get into later classes. You can click the scroll wheel and move things around. I think you can also right click, so you can still do it with a trackpad. It's just a lot more clunky, and if your trackpad doesn't have a separated button, you're going to have all kinds of issues moving around. Sometimes you'll do something bizarre like move it off the screen, hit this zoom to fit to bring you back to whatever your part is that you're working on. You can also take components and you can rotate them. using this tool, and you can delete them. You want to look at both the basic and all components. We're going to be using stuff from the all components list frequently, but there's a whole bunch of sensors here and other things that you guys are going to be able to use with great regularity. Motors, displays, all sorts of other things. Breadboards, the full-size breadboard is going to resemble very much what you have in the kit, but the labeling for the breadboard on this smaller one is a lot better in order to just kind of get things started. So we'll talk about that. The Arduino Uno R3 is exactly the same model as what you're going to be using in your kits, and they have a code window here that allows for options. You always want to switch this over to text because you just do, for a whole bunch of reasons. They've included some additional labeling and things here, but the idea is you can download, and I think they may have just done an update. There was an issue this last few weeks where if you downloaded the code, the INO file didn't exactly work. There's another software that we'll talk about here in a little bit that's going to be part of what you need in order to complete this for the semester. So before we get into some of the code things, we'll come back to that later. We want to think about first, from even just the basic components list, we want to think about how to make a couple things work in a circuit. So the breadboard, you can see, as you're scrolling forward and back, you can zoom in or out. A couple things like that are very useful. You can also undo and redo movements. We'll talk about wires and a couple disciplines here. So I'm going to go ahead and connect up a battery real quick. I'm just going to do it the lazy way here. Now, notice the rails have these green highlights. That's showing you the connectivity, meaning anything I connect to this negative rail is all going to be connected together to whatever it's connected to. So, same thing with the positive, and the red and black is the common convention. You've seen it if you've ever opened up electronic toys and things. Almost always red and black wires coming from the battery. Same thing in vehicles, same thing in a lot of other areas of life. Red and black is very common. Red denoting positive, black denoting ground. So there's a couple other things that you want to pay attention to, and one of them is things like this, for instance. So if we just had a connection, we want to connect a wire, we're just going to click on a couple of those places, and we're going to change that color to red because this is bringing power in. So if we just connect up a 9 volt, we hit start simulation, this is how we run all of our circuits, what you're going to see is fire. Fire is bad. There's a reason we're teaching you how to do digital prototyping first and then move into some of the other things. So 915 milliamps is way too much for these little LEDs, and this is something that you're going to be able to see in a lot of the projects that we're going to work on. And what we're going to be able to do is we're going to be able to use this to help troubleshoot things before we set fire to real actual components. So you want to stop the simulation, we're going to delete this, we're going to drop a resistor into place, and now we have this working correctly. So couple quick recap items. You want to use red for positive, black for ground. Make sure they're going into the right rails and not shorting things. You want to make sure that wherever you're using LEDs, you have resistors in place. Now, if I flipped this resistor around and went the other way, and I started the simulation, unlike a light bulb, it doesn't work. So this is a big problem. So one of the things that you want to do is you want to pay attention to how things, and every time you go to move a component, incidentally, or change code, you have to stop the simulation to move parts around. Two sides, cathode, anode. The long side is the anode. But if you don't remember all the stuff from chemistry, the simple way to remember this is cathode is negative because cats are evil. So now you can never unhear that. But because cats are evil, this is always negative, and you have a whole lot more options as far as how some of this gets operated. The discontinuity, guys, sorry for the audio changes. Nothing really I can do about it. There's a whole series of things making this difficult. All right, so we're going to take out this 9-volt battery from where we are. Audio at least shouldn't be bouncing off the rev limiter here, like some kid that's just figured out there is a rev limiter. All right, so here's what we're going to do is we're going to transition over to the example. So if you followed anything of the links in Halo, you will see that we do have some examples, or there's an example linked. So over on the right side in topic 1 under resources, you're going to find this one. So I'm going to open up this one, and I'm also going to open up a second version. You'll see why here in just a couple seconds. So there's 2 instances that we need of this, and one of them is showing an example of how things are done properly. So I'm going to make the quick adjustment so that it matches the initial state of what you guys are going to find. So you'll see that I have just moved a resistor. We're going to talk about a couple of reasons why. So when you go to start this and simulate it, you have a reset button and you have a roll button. What we're trying to do is we're trying to replicate this. So I want you guys to work on recreating this. And you'll find that here again, the code is already present here in the form of, we have to stop to make any edits or any copies, in the form of this text. You want to do text only, a whole bunch of reasons why. We're not trying to get you to understand all of the fundamentals of programming, we're just trying to get you to see how some of these things work and operate. So the code is already given to you in this format. You're also going to want to grab from Arduino.cc. If I can spell it right, that'll really help. Arduino.cc. What that does is you can go to their software tab and you can see what's actually, you can see a couple of the installer options. I would skip the Windows app and just do the actual full Windows program. A whole bunch of reasons why, and then if you made life harder on yourself by starting with a Mac, they do have a Mac installer as well. So you can install those and run them. We're going to talk about some of the details of what this works like, how this software runs. It's an IDE, an integrated development environment. So if you guys have ever worked with code in the past, the kind of general functional parameters will be similar to other things you've seen. They won't necessarily be identical. Arduino uses a mostly C++-like language, but you guys will learn a lot more depth about this in future classes with programming and some other things. So let's start with the example and show you. Once we're done, we should be able to download this. I'm hoping they did an update because there was an issue recently where when you downloaded it, you get this INO file, you take the copy of the INO file, so let's test it live, nothing like doing live testing, and see if we can break things, because that's usually the best plan you can come up with. So you open up a copy, and so it's still failing to open the sketch. And yeah, so this is a previous version that I had where I've made some changes to things. We'll talk about that in a minute. So the theory is you're supposed to be able to download the code, open it in the Arduino IDE, and load it directly onto the board. Instead, you're going to have to start a blank sketch, copy the whole block of code, paste it into the Arduino IDE, and that's as simple as copying and pasting in a Word doc. We'll talk about the last steps for configuration in the Arduino IDE. So you go to run this and you get this example and it's working great and it's rolling the dice, and then you go to build it on your board. I recommend building a slightly simplified version that looks something like this, but what you're going to find is if you hook it up the way that it has been, you're going to find that it does something like this, where it's dark and nothing happens. And then you're going to wonder why. And then you're going to go try and get tutoring help. And then they're going to go, well, I'm pretty sure it's a code problem, but I don't know why the display isn't lighting up. And then you do some research, and then you figure out, well, this is actually a different type. So we have to select the cathode type display. That means these common ports actually have to be connected to a negative. So when we do that, and we build our actual device, if we take a look at this, and we switch real quick to a cathode type, so I might have to reload, okay. Sometimes you'll have to reload the interface with Tinkercad, sometimes you don't. So if we switch it to cathode type, we have to switch this to negative, and then we'll see what the code looks like. So the strange thing is we're actually seeing exactly the same thing that we used to be seeing except because the polarity of the device that we actually got in the kit is opposite of the polarity that this code was designed for, the part that's dark is actually the number you're interested in, you see. And so this is actually a 0. If we go to roll it, obviously we get a 2 here, because the part that's dark and left over is a 2. And then, so it's not working wrong. Here's a 5, right? Here is, let's see a couple other numbers just to demonstrate that it does, there's a 2 again, so it does work. However, see, here's a 4, so that's good. Because we now live in opposite land, this is what happens when, let's say, theoretically speaking, if you had a pandemic. And then let's say theoretically that pandemic locked down a whole bunch of the world. And then theoretically speaking, if that caused all kinds of production shortfalls and supply chain issues and chip shortage and a bunch of other malfunctions where you couldn't get the same things from the same suppliers and sort of all of those things, as you start kind of looking through and trying to troubleshoot some of these things, you quickly realize that you can end up with different parts than what you might otherwise. So, here we are with a different display part than what we expected from the kit, but it's not one that's defined. So, how do we fix this? Because you've got the display lighting up, but you can't sell this as an end product to the user, right? Because all the 12-year-olds on the internet will give you bad YouTube reviews, and then your company will go out of business. Modern business is really kind of tricky that way. So what I recommend you guys doing is you'll see an updated attachment, at least for those that are in my sections. The other instructors should have updated them as well. In the event that they haven't, I'll show you quickly what changes. This is still the same type, still the cathode type. That's the physical part that's on the boards that you build, and what you're going to have is a statement right here that's dropped in right after the temp assignment. So temp 1 equals for all of these, all the way down. For temp 1, what I did is I used a serial print line to tell me some information back out, and then told the computer, okay, since we're now in opposite land, because these kinds of chip shortages and different problems with different suppliers and parts coming from different areas and not being able to order exactly the part that you needed, and you can only get certain parts at certain times of the year, and all these things that have happened is a real engineering example. So instead of fixing it, we left some of this intentionally broken to give you a real-world example of how we do troubleshooting as engineers, because we don't get to give simple answers like, I don't know, or it's Bob's fault, because unfortunately at the end of the day, we actually have to fix whatever it is that's not working. So we include this if-else block. So it's saying if the temp is 0, then actually reassign it and pretend it's a 1. And if it's a 1, then actually reassign it as a 0. So I take it and digitally flip the polarity of what we're trying to do to switch displays on or off. When that's done for each of those blocks, what we see is there's the reset on this one. I have them hooked up in reverse of what the other one did, but as long as it's going to the same analog pins, you'll figure it out. You'll get some numbers like this. The problem with the code is there's still an initialization issue in one of them where you have an extra piece, this display element F is being told to turn on all the time. So F and this center bar are running all the time. So we are getting numbers. 4 works correctly, but because of these two display elements being illuminated basically all the time, this is either a 4 or a 1. And this is another problem in the code that instead of taking lots and lots of hours to go fix, it's a lot easier to explain how this is working. It does demonstrate the proof of concept, but it also demonstrates the difficulty of having to re-engineer a system that was already designed and spec'd for a certain list of parts in order to build the end product. This is where some of the difficulties come in. So in real engineering, we really have to go in and rewrite the code and change things to accommodate the different hardware. And so you can see you really actually do roll 6s, you do roll 4s, you roll 2s. This is actually a 3 because this one is illuminated, because you can't actually roll a 9 from a 6-sided die, although if you manage to do so, I will be exceedingly impressed. There are a couple other ones that I wanted you to see an example of, so I'm hoping it gives me, here it is. So this one is actually a 2. It's not really a G or a Q or whatever this is. So it's actually a 2 because this one's always illuminated. The rest of them you can pretty well figure out. So the objective is, there's our 3 again, the objective is to try and get you guys to understand how to connect this up on the actual physical board, and then once we've got that operating, we take this code, we copy it, we paste it into the Arduino IDE, and it looks something like this. We have our board built, we physically connect the USB connector, and then what we're going to get is we're going to get under Tools, the port is going to show up, and we're going to be able to select some port. It's going to probably be somewhere between COM 3 and COM 7, typically, and that's going to have the words Arduino Uno on it, and we're going to select that one. Then, because this is already done, we're going to hit Upload, which is going to do what's called the verify. It's going to go through and compile the sketch. Then it's also going to, once it's compiled the sketch and determined that it doesn't have any egregious code violations for syntax and things, it will actually upload it to the board when you hit the Upload button. So it'll go through, it'll compile, it'll say, yes, this is fine, then it'll try and upload onto the board, and so long as you don't have a short, it'll say done compiling, then it'll be uploading, then it'll say done uploading. If you do not get this light showing up on your board, there's a green LED here that will light up as on, and then there should be a blinking LED here that's loading content when you actually start it up. If that's not happening, and you have everything dark, and you notice this spot on your Arduino Uno getting really warm, probably what has happened is you have inadvertently crossed power and ground somewhere, so you want to go back and really double check connections to make sure they are correct. Because if you have positive and negative, something like this, all together, it should demonstrate for us exactly what that looks like. So if I were to connect, actually I want to connect it here because I'm doing it wrong. It's really hard to consciously override this because I know this is bad. So if we connect up 5 volts and ground on the same point, what we should get is a short. Now in this case, we're not seeing it, but that's what we should actually get. So it's not going to catch all the possibilities. But that's, if it's like this, and you have them power and ground in the same line, you're going to have a short, and it will heat up the Arduino, and you can actually damage the board itself. So if you don't have the on light illuminated, unplug it and double check for a short, and make sure that things are taken care of. So we'll learn a lot more about a lot of these other things later in the semester, but this will hopefully give you guys a sense of where to start, and then there's some additional troubleshooting and things that are going to be pasted elsewhere on my page.